Here's another example dealing with probability from the textbook. The U.S. Postal Service reports 95% of first-class mail within the same city is delivered within 2 days of mailing time. 6 letters are randomly sent to different locations. What is the probability that all 6 arrive within 2 days? So the first thing when we read this question is we need to determine which type of probability we need to consider. It doesn't tell us as a normal distribution, so we can forget that. So our other is just a regular discrete probability, or we can have a binomial probability. So here we have either the mail gets there in 2 days or it doesn't. We know we're dealing with 6 letters, so we know n, and one letter getting there doesn't affect the other letter getting there, so they're independent. So right away, this is a binomial distribution. Binomial. So now we know what we're going to do to get the results, but that's got to be your first step. What kind of distribution? So we're asked to find what is the probability that all 6 arrive the same day. So the probability that x would be equal to 6. And the things we need to consider, well, we know that the probability of success, so probability of success is 0.95. And we know that n is equal to 6 because that's how many letters we have. So we want to know what is the chance that all of them are successful. So in our calculator, we're going to do binomial PDF. So we're going to go second function, distributions, and we go to binomial PDF because we want exactly 6. And the number of trials, we have 6 trials. Our value of P, success, is 0.95, and we want all 6 of them to arrive successfully. And there's our result. So the probability that all 6 arrive is 0.735. B, what is the probability that exactly 5 arrive within 2 days? So we're just going to do exactly the same thing, except I'm going to change the last 6 to a 5. And we get that answer. The probability of x equal to 5 is therefore 0.232. And you can see how this would make up part of a probability table or probability distribution. This would be x6, x5, and we could use the calculator to get 0, 1, 2, 3, 4, or 5 and 6 we already have. Find the mean number of letters that will arrive within 2 days. Well, the expected mean for a binomial distribution is simply n times p. So because we know it's binomial, we just have to do n times p. N is 6. Probability of success is 0.95. And that's just a simple arithmetic on our calculator to see the answer is 5.7. So we would expect nearly 6 of the letters would arrive on time, or within 2 days, which makes sense given the data. So now we need to know what is the variance and standard deviation. So variance is this, standard deviation is simply the square root of that. For, again, a binomial distribution, the standard deviation is the square root of n times p times q. Again, for a binomial distribution, which means the variance is simply n times p times q. N is 6. Success is 0.95. Failure then is 1 minus that, or 0.05. And that's going to give us 0.6. That's not right. 0.95 times 0.05 times 6. So that's our variance, 0.285, and the square root of that is our standard deviation. Square root of the answer is 0.534. And so that's that example. Remember, pick which kind of probability you're dealing with, then proceed to answer the questions. Binomial, we use binomial features in the calculator. The mean and variance and standard deviation we have simple formulas for. For a normal probability distribution, we have our procedures we use in the calculator. For just a standard discrete probability distribution, we have our procedures we use. So the first thing you need to do is determine what way you're going to solve it, and then proceed from there.